Okay, in part 4 of this video series, we're going to look at how we can manipulate a spreadsheet in the context of um, rectangular area so that we can narrow down um, our values to a particular range where we're able to see the dimensions that do produce the minimum perimeter. So recall in the last video we have a good feeling that the square is going to be the figure that produces the minimum perimeter given a fixed area. So what I'd like to do is insert. So I'm going to put my cursor over this column. I'm going to right click and I'm going to insert. That is a row just above, and in that row I'm going to come down 1/10 of a meter. And over here I'm going to fill down the formula into this column to calculate the length, and let's just verify. We are taking cell D4, that's the area, and dividing it by the width to give the length, so that works. And over here, the perimeter, we're just going to fill this down as well. And we end up with 19.6 again. So that doesn't seem to help all that much. But what we can do is this. We've set this dimension to be 4.9. This one, on the other hand, may not exactly be 4.9. Perhaps there's been some rounding. So if I come up to the toolbar up here, you'll notice that this one says to increase the decimal. So I'm going to give this a few decimal places. So you can see that it is 4.898. This one, on the other hand, is 4.9. Okay. I can do the same thing on the perimeter column, and we'll get 0.596. Okay. Let's come on down to this column here. Let's increase our decimal places. Okay, so those are true values. So we can see right now that at 4.9 the perimeter is slightly smaller than when it is at a width of 5 and a length of 4.8. So just to make this more conclusive, let's add one more row in. So let's insert a, actually that was in the wrong spot, so let's undo that change. We're going to go here over row 8 and insert. I'm going to use 4.8. And here I'm going to copy and fill down. Again, we have 5. Okay, we could even narrow it down even more. We could add a column in here. And we could use 4.85 if we like. We'll add some decimal points to this. And there we have it. So you can see here that at 4.9, this is roughly 4.9, our perimeter is at its minimum at 19.596. So when we go back to the question, or to the problem, the least perimeter for a four-sided pen with 24 squared meters is approximately 19.5 or 19.6 meters, and the dimensions that produce that are approximately 4.9 meters. So in this case, the square is the rectangle for this four-sided enclosure that produces the minimum area with a fixed perimeter of 24 square meters. In the next few minutes, perhaps the next 5, if you haven't had a chance to complete the practice problem or to take time to reflect on the work that you've done, then pause the video here and do so. If you do have some time remaining, you should go ahead with the extension problems. That is parts C through F. Okay, each of those will be done in notebook software, which is the software I typically use within the classroom. Notice that in part C, we've already alluded to that. Okay, we could have predicted these dimensions by using the square as our model rectangle. So in part D, we're going to move away from the spreadsheet and we're going to attempt to do some algebraic work to determine the answer to this. Okay, so at this point in time, if you're ready for this information, you should pause and you should give some thought to trying to figure this out on your own algebraically, and then watch the video back to see if you've got the right thinking in mind. Okay, so part C was already mentioned. And in part D, let's look at the algebraic thinking behind this. So if we're to determine the side length of the square, take the square root of the given area. So using this formula, we can see that the area, that is its square root, is about 4.9 meters. And from those dimensions, that is the side length of a square, you can determine its perimeter. Recall that perimeter is 4 times that value, or its area is simply side times side, or length times length, length times width.